Right now, at this exact moment, you are somewhere. You know where you are. You could describe it to someone. But here's the wild thing. For most of human history, you would have had absolutely no way to communicate your precise location to someone who wasn't standing right next to you. Think about that. For thousands of years, humans had language, writing, mathematics, agriculture, cities, empires. But we had no universal system for saying, "I am here," in a way that someone else could use to find you. Today, you can text someone a pin drop and they'll know your exact location within meters. You can order a pizza to a specific apartment in a building you've never visited. You can receive a package from across the world, addressed to you, personally. This seems normal now, but it's actually one of humanity's most underrated achievements. We invented a language of location, multiple languages actually, and each one reveals something profound about how we organize space, information, and society itself. So today we're going to trace the evolution of how humans learned to find each other, from the first street names to GPS coordinates to systems so advanced they make the address itself obsolete. And along the way, you'll discover why some of these systems are secretly brilliant, while others are accidentally broken. Let's start with the fundamental challenge. You need to tell someone where something is. Simple, right? Just describe it. It's by the big oak tree. Perfect. Except what happens when the oak tree dies? It's near the blacksmith shop. Great, until the blacksmith moves. It's where the battle happened, Morris. Wonderful. But which battle and how many people actually remember where that was? For most of history, location was relative and temporary. You describe position based on landmarks that everyone in your immediate community recognized. This worked fine for small villages where everyone knew the same reference points, but it completely breaks down at scale. How do you direct a stranger to a specific house in a city of 10,000 people? And now, how does a merchant deliver goods to someone they've never met? How does a government census taker find every residence? The answer humanity eventually developed was simple and revolutionary. We imposed an artificial grid on top of the organic chaos of settlement. We decided that every street would have a name and every building a number. This seems obvious now, but it was a radical shift in thinking. Instead of describing location based on what naturally exists there, we created an abstract reference system that exists independent of the physical reality. But here's what's fascinating. Different cultures approach this problem in wildly different ways, and those differences reveal deep assumptions about how society should be organized. Some systems prioritize memorability, some prioritize logic, some prioritize flexibility, and some, as we'll see, prioritize efficiency for machines over comprehension for humans. When cities started systematically naming streets and numbering buildings, they had to make fundamental choices. Should the names mean something or be arbitrary? Should numbers run sequentially or encode information? These weren't just technical decisions, they were philosophical ones about how humans interface with space. Take American cities. Many followed a grid pattern with numbered streets running one direction, and named streets running perpendicular. First Street, Second Street, Third Street. Simple, sequential, easy to navigate. If you're on 5th Street and need to get to 12th Street, you know immediately that you're 7 blocks away. The number tells you distance. That's elegant. But then you get European cities with streets named after historical figures, events, or landmarks. Shakespeare Street, Victory Avenue, Cathedral Road. These names carry meaning. They tell stories. They connect the present to the past. You navigate not by abstract numbers but by cultural memory. That's also elegant, just optimizing for different values. Japanese addresses take an entirely different approach that blows Western minds. In most of Japan, streets don't have names at all. Instead, cities are divided into districts, then blocks, then buildings, and addresses specify this hierarchy. You don't navigate by following named streets. You navigate by understanding the nested structure of the urban organization. It's like file folders on a computer. City, district, block, building. This seems impossibly confusing to outsiders, but it reflects how Japanese cities actually grew organically, rather than being planned on grids. Each system works within its context. Each makes certain tasks easier, and others harder. Each assumes certain things about how people think about space, and all of them run into the same fundamental limitation. They only work if you already know roughly where you're going. This is where postal codes enter the picture, and they're solving a completely different problem than addresses solve. The address tells you the destination, but if you're a postal service moving millions of letters every day, the destination is the last thing you need to know. First, you need to know the journey. Which sorting facility does this go to? which truck, which route, which delivery person. This is the genius of postal codes that most people never think about. They're not for you. They're for the system. They're routing instructions disguised as location identifiers. When you write a zip code on an envelope, you write to why, at banks to you call jai. Bin prasturbine, nu not. Telling the postal service where you live. You're telling them how to get your letter there. Let's break down how this actually works using the American zip code as our example. 5 digits. Simple. But each digit is a decision point in the sorting process. The first digit divides the entire country into 10 massive zones. 0 for the Northeast, 9 for the West Coast. When your letter hits the first sorting facility, that first digit tells the workers or machines which direction to send it. East or west. That's it. One giant fork in the road. The second and third digits narrow it down to a specific sectional facility, a regional sorting center that handles a particular geographic area. Now your letter is in the right part of the country, headed to the right regional hub. The fourth and fifth digits specify the local post office that will actually deliver your mail. At each stage, sorters only need to look at the relevant digits for that stage. They don't need to read your full address until the letter is on the truck for final delivery. This is why zip codes create such weird geographic patterns. They're not trying to create neat, logical boundaries. They're optimized for logistics. A town on the border of 2 states might share a zip code with the neighboring state if that's more efficient for delivery routes. Rural areas might have one zip code covering hundreds of square miles, while dense urban blocks each get their own. The code follows the infrastructure, not the political boundaries. And this reveals something important about how systems evolve. The address system was designed for humans to understand. The postal code system was designed for operational efficiency. They serve different masters, they optimize for different things, and they have to coexist, creating redundancy and occasional confusion, because each solves a problem the other doesn't. But here's where things get messy. Postal codes were designed by logistics people for logistics purposes, but they have to be used by regular humans who don't think like logistics people, and this creates friction. The United States tried to add 4 more digits to zip codes in the 1980s. The zip plus 4 system would have provided even more precise routing, getting mail sorted down to specific buildings or even floors. From a logistics perspective, this is brilliant. From a human perspective, it's annoying. Americans had already memorized 5 digits. 5 digits already worked. Why should they memorize 9? And so almost nobody uses zip plus 4 except businesses and people who really care about postal efficiency. The system exists. It works. It makes delivery faster. But it failed to achieve adoption because it violated a fundamental principle of system design. People won't use features they don't need, even if those features would help them. This is the constant tension in infrastructure design. Engineers want optimization. Users want simplicity. Engineers see inefficiency and want to fix it. Users see something that works and don't want to learn something new. Neither is wrong. They're just optimizing for different things. The UK found a clever middle ground with their postal codes. They use letters mixed with numbers, creating codes that are longer than American ones, but more memorable. And because the UK is smaller and denser, their postal codes can be precise enough that in many cases, you could theoretically deliver mail with just the postcode and house number, no street name needed. The code essentially replaces the address rather than supplementing it, but even the UK system is still fundamentally designed for the old world of human sorters reading codes and making decisions, which raises an interesting question. If we were designing a postal code system today, from scratch, with modern technology, would we design it the same way? But here's where things get messy. Postal codes were designed by logistics people for logistics purposes, but they have to be used by regular humans who don't think like logistics people. And this creates friction. The United States tried to add 4 more digits to zip codes in the 1980s. The zip plus 4 system would have provided even more precise routing, getting mail sorted down to specific buildings or even floors. From a logistics perspective, this is brilliant. From a human perspective, it's annoying. Americans had already memorized 5 digits. 5 digits already worked. Why should they memorize 9? And so almost nobody uses zip plus 4 except businesses and people who really care about postal efficiency. The system exists, it works, it makes delivery faster. But it failed to achieve adoption because it violated a fundamental principle of system design. People won't use features they don't need, even if those features would help them. This is the constant tension in infrastructure design. Engineers want optimization. Users want simplicity. Engineers see inefficiency and want to fix it. Users see something that works and don't want to learn something new. Neither is wrong. They're just optimizing for different things. The UK found a clever middle ground with their postal codes. They use letters mixed with numbers, creating codes that are longer than American ones, but more memorable. And because the UK is smaller and denser, their postal codes can be precise enough that in many cases, you could theoretically deliver mail with just the postcode and house number. No street name needed. The code essentially replaces the address rather than supplementing it. But even the UK system is still fundamentally designed for the old world of human sorters reading codes and making decisions. Which raises an interesting question. If we were designing a postal code system today, from scratch with modern technology, would we design it the same way? Ireland decided the answer was no. And what they did is either genius or insane depending on your perspective. When Ireland implemented their postal code system called Aircode, they made a radical choice. Randomness. Complete, total, intentional randomness. Traditional postal codes try to be memorable and logical. London gets L codes. Manchester gets M codes. Numbers increase as you move outward from city centers. There's a geographic logic humans can learn and remember. Ireland looked at all of that and said, why? Why should humans be able to figure out the pattern? The machines are doing the sorting now. The machines don't care if the codes make sense. They just need the codes to be unique and precise. So, Ireland divided the country into routing zones and gave each zone a random 3-character code. Cork got T12. Limerick got V94. Waterford got X35. There's no pattern. You can't figure out what region you're in based on the code. It's deliberately meaningless to human interpretation. But then Ireland went further. Every single delivery point in the country got 4 additional random characters. Your house gets a code. Your neighbor gets a different code. The building next door gets another code. All random, all unique, all completely unmemorable to humans but perfectly clear to machines. And here's the brilliant part. Those last 4 characters aren't actually random. They're GPS coordinates in disguise. Each code corresponds to a specific geographic point. Feed that code into a computer and it knows exactly where your front door is located on the planet. The sorting machines know where every mail truck goes. They know where every delivery point is. They can optimize routes in real time based on traffic, weather, or package volume. From a logistics perspective, this is beautiful. It's a system designed not for the past but for the future. It assumes machines will do the sorting. It assumes GPS navigation. It assumes digital databases. It doesn't care about human memorability because humans won't need to memorize it. They'll just copy and paste it from their phones. But from a human perspective, it's alienating. You can't tell anything about where someone lives from their air code. You can't navigate by understanding patterns. You can't estimate distance. The code is opaque. It's a black box. You input the code, and the machine tells you where to go. You're entirely dependent on technology to interpret it. And this brings us to the fundamental tension in all location systems. Do you design for humans or for machines? Do you prioritize understanding or efficiency? Do you value memorability or precision? Traditional postal codes tried to be both human-readable and machine-sortable. They mostly succeeded, but they made compromises. They're not perfectly precise. They require updates when boundaries change. They're not optimized for modern logistics technology, but humans can remember them, understand them, and use them without digital assistance. Ireland's system makes the opposite trade-off. Perfect precision, perfect flexibility, future-proof technology, but completely opaque to human understanding. You need a device to use it effectively. You're dependent on databases and GPS. If the technology fails, the codes are useless. Neither approach is wrong. They're different philosophies about what a location system should be. And this same tension exists across all kinds of infrastructure. Do you design roads for driver intuition or for autonomous vehicles? Do you design interfaces for human comprehension or for AI assistance? Do you optimize for the present or the future? There's an old system still in use that nobody thinks about, but reveals this tension perfectly. Traditional addresses themselves. When you write 123 Main Street, you're using a system designed centuries ago for a world without computers, without GPS, without databases. It's designed for a postal worker on foot who knows the neighborhood, can read street signs, and can count building numbers. That system works remarkably well even today, but it's also full of inefficiencies that modern technology could eliminate. Duplicate street names in different towns, irregular numbering, missing numbers where buildings were demolished, Addresses that changed when streets were renamed. It's a mess if you think about it systematically, but it's a mess that humans can navigate because it matches how we actually think about physical space. This raises a fascinating question about the future. Do we even need addresses anymore? With GPS, every point on Earth already has precise coordinates. Latitude and longitude can specify any location to within centimeters. Why do we still use street names and building numbers at all? The answer is that GPS coordinates are terrible for humans to use. Try memorizing your home's coordinates. Try saying them out loud over the phone without making a mistake. Try writing them down without transposing digits. Coordinates are precise, universal, and completely unusable for everyday human communication. This is why systems like What 3 Words emerged. They divided the entire world into 3-meter squares and gave each one a unique combination of 3 random words. So instead of coordinates, you can say table, lamp, elephant, and that refers to one specific spot on the planet. It's more memorable than coordinates. It's more precise than addresses. It's designed for humans while being perfectly readable by machines, but it also has the same problems as any proprietary system. It's controlled by one company. The words are arbitrary. Different languages get different words for the same location. It's clever, but it's not organic. It's imposed from above rather than emerging from how people naturally communicate location. And that might be the real lesson here. Every location system is a compromise between precision and usability, between machine efficiency and human comprehension, between universal standards and local knowledge. The best systems aren't the most technically perfect. They're the ones that match how humans actually think while being good enough for the technology to work with. So what started as a simple question about postal codes has revealed something deeper about how humans organize information, how we interface with technology, and how we make trade-offs between different kinds of efficiency. The evolution from street addresses to postal codes to GPS coordinates to random air codes isn't just about mail delivery. It's about the shifting relationship between human cognition and machine processing. Early systems were designed entirely for humans. Modern systems are designed increasingly for machines, with humans as an afterthought. Future systems might eliminate humans from the loop entirely, and this pattern extends far beyond location. Think about how you navigate. You probably don't memorize directions anymore. You follow GPS turn by turn. You've outsourced spatial reasoning to your phone. Think about how you remember phone numbers. You probably don't. Your contacts list does that for you. Think about how you find information. You don't memorize facts. You know how to search for them. We're living through a transition where human-readable systems are being replaced by machine-optimized systems that humans access through interfaces. The underlying complexity is hidden. The actual information is abstracted. We're becoming dependent on technology, not just to enhance our capabilities, but to access systems we can no longer understand directly. Is this good or bad? It's probably both. We gain precision, efficiency, and capabilities that would be impossible with human-only systems. But we lose independence, understanding, and the ability to function when the technology fails. We gain a world where you can find anyone anywhere with perfect accuracy. But we lose a world where location has inherent meaning that humans can comprehend. The postal code was never just about mail. It was about designing systems that bridge human understanding and machine efficiency. And as we build more complex systems in more domains, that bridge becomes the critical question. Not just what can the machines do, but what should humans still understand? Not just what's most efficient, but what trade-offs are we making? Because in the end, these codes, these addresses, these systems for finding each other, they're not just technical infrastructure. They're languages. And every language shapes how we think, what we can express, and how we connect with each other. The language of location is no different. And it's still being written. Thanks for watching.